Imagine a silent intruder slicing through the velvet black of space, hurtling toward our sun at speeds no rock from our solar system could dream of matching. 58 kilometers per second, a whisper from the stars themselves. Discovered just months ago on July 1st, 2025, by the vigilant eyes of NASA's Atlas Survey Telescope in the crisp Atacama Desert of Chile, this visitor defies the quiet routine of celestial mechanics. Designated 3I/ATLAS, the third confirmed interstellar object to breach our cosmic borders, it arrives not as a gentle wanderer, but as a harbinger of questions we may never fully answer. As it grazes the inner edges of our planetary family, passing a mere 0.19 astronomical units from Mars on October 3rd and reaching its solar closest approach on October 29th at 1.36 astronomical units, telescopes worldwide strain to capture its fleeting secrets. But what began as a routine observation has spiraled into something far more profound. Anomalous emissions, a composition that echoes ancient stellar nurseries, yet twists our understanding of cometary birth. And now, with its final bow before vanishing into the outer dark, the James Webb Space Telescope's latest footage, captured in the tense hours of late November 2025, has ignited emergency convenings among astronomers, astrobiologists, and even policymakers. This is not just a comet's passage. It's a mirror held to the universe's vast, indifferent intelligence, forcing us to confront how perilously thin the line is between the natural and the unknowable. For those who gaze upward with a scientist's precision or a poet's wonder, the story of 3I/ATLAS unfolds like a thriller scripted by gravity itself. Born potentially billions of years ago in the turbulent disk of another star, perhaps one nestled in the Milky Way's thick disk, where ages stretch back 7 billion years or more, this icy relic was flung into the interstellar void by some cataclysmic gravitational slingshot. Its hyperbolic orbit, with an eccentricity exceeding 6, confirms it. Unbound by our sun's pull, it will exit as swiftly as it entered, slingshotting toward the constellation Gemini by mid-2026. Pre-discovery images, unearthed by amateur sleuth Sam Dean from Atlas Archives dating to June 5th, reveal why it evaded earlier detection. Its path overlapped the dense star fields of the galactic center, a cosmic camouflage of blinding lights. By July 2nd, confirmations poured in from the Deep Random Survey in Chile, Arizona's Lowell Discovery Telescope, and Mauna Kea's Canada-France-Hawaii Telescope, spotting a faint coma, that hazy envelope of dust and gas, stretching just 3 arc seconds, a telltale sign of activity. Reddish hues in the coma, captured by the Nordic Optical Telescope, hinted at iron-rich dust, while the tidy observatory's twin 2-meter scopes measured a diffuse glow, active yet restrained, as if the comet were awakening slowly to our sun's warmth. What elevates 3/ATLAS from curiosity to compulsion is its chemistry, a molecular fingerprint that whispers of worlds we can only model in simulations. Early spectral scans from the European Southern Observatory's Very Large Telescope detected cyanide gas, CN, and atomic nickel vapor at levels mirroring solar system comets, familiar yet sourced from afar. But it was the James Webb Space Telescope's gaze on August 6th, with its near-infrared spectrograph piercing the infrared veil, that unveiled the anomaly. A coma dominated not by water vapor, as in most comets, but by carbon dioxide with a staggering CO2 to H2O ratio of 8:1, the highest ever recorded. According to NASA's preliminary analysis, released August 25th, the nucleus ejects 129 kilograms of CO2 per second, alongside modest 6.6 kilograms of water, 14 kilograms of carbon monoxide, and trace 0.43 kilograms of carbonyl sulfide. Water ice grains, finer than a micrometer, scatter in the coma, their absorption features at 1.5, 2.0, and 3 microns betraying a pristine, irradiated crust perhaps 15 to 20 meters deep, forged by eons of galactic cosmic rays bombarding its journey. No carbon chain molecules like C2 or C3 appear, rendering it one of the most depleted comets known. a ghost of volatiles long sublimated in the cold between stars. This composition stirs a quiet urgency among researchers, for it suggests 3I/ATLAS formed in a cooler, more carbon-rich nursery than our own Oort cloud. Preliminary models from the Harvard-Smithsonian Center for Astrophysics posit an origin in a protoplanetary disk around a low-mass star, where CO froze out early, preserving this icy menagerie. Yet as the comet hurtled inward, its behavior grew erratic. Ground-based observatories noted a subtle non-gravitational acceleration, a nudge beyond solar gravity's grasp, echoing the enigmatic push of Oumuamua in 2017. Unlike that cigar-shaped enigma, 3I/ATLAS shows clear cometary traits. No visible tail in early images, but a teardrop-shaped dust cocoon imaged by Hubble on July 21st from 277 million miles away. That Hubble shot, with streaked background stars from the comet's relentless motion, estimated a nucleus perhaps 1 to 2 kilometers across, far larger than Oumuamua's 100 meters, yet light enough to evade precise mass readings. The asymmetry in its coma, rich in gas yet sparse in dust, implies uneven outgassing, perhaps vents on one hemisphere, heated asymmetrically as it tumbled end over end every few hours. As September dawned, the global observatory network intensified, a symphony of light-gathering machines from Chile's Paranal to Hawaii's summits. NASA's SphereX, launched just months prior in 2025, joined the fray from July 7 to 15, its spectrophotometer mapping the coma's diffuse glow across ultraviolet to near-infrared, confirming the CO2 dominance and spotting faint hydroxyl radicals, breakdown products of water dissociation under solar UV. Yet whispers of concern rippled through virtual corridors. Data from the Zwicky Transient Facility at Palomar hinted at irregular brightness fluctuations, not the smooth dimming expected post-perihelion, but spikes suggesting internal restructuring. Was it fragmenting like the ill-fated C/2019 Y4 Atlas of 2020? Or something subtler, a release of trapped gases, altering its albedo mid-flight? These anomalies, though within natural bounds according to ESA's Near-Earth Object Coordination Center, prompted Avi Loeb, Harvard's bold astrophysicist and Oumuamua provocateur, to revive his OEP scale, the object of extraterrestrial probability, a Torino-inspired metric grading interstellar oddities from 0, mundane rock, to 10, undeniable text signature. In a September preprint, Loeb pegged 3I/ATLAS at level 3, multiple quirks including the CO2 excess and acceleration, warranting 20% odds of non-natural origin. It's a statistical shadow, Loeb cautioned in a TEDx talk, but shadows lengthen when the light is strange. The emotional weight of such speculation lands heaviest in the quiet hours of data review, where scientists sift pixels for patterns that could rewrite textbooks. For young astronomers, many in their 20s, this is more than equations. It's a brush with eternity, a reminder that our sun is just one flare in a galaxy teeming with ejected orphans. One postdoc at the Jet Propulsion Laboratory confided in a late-night webinar, "Staring at those spectra, I felt the chill of interstellar space on my skin. These molecules have outlived stars. Yet science demands restraint. NASA's Swift Observatory, scanning X-rays, estimated a diameter up to 4.94 kilometers based on water emission, but cautioned it's likely overstated. The coma dominates, not the nucleus." Mars Orbit offered a gift on October 3rd, ESA's Mars Express and Trace Gas Orbiter, alongside NASA's MAVEN and Mars Reconnaissance Orbiter, turned skyward. MAVEN's imaging ultraviolet spectrograph mapped hydrogen clouds in the coma, revealing hydroxyl outflows at rates 10 times solar system norms, while HiRISE on MRO captured the fuzzy envelope from 30 million kilometers, fainter than expected, yet pulsing with UV emissions. China's Tianwen-1 orbiter added infrared frames on October 6th, its multispectral camera unveiling a reddish dust tail 10 arcseconds long, laced with silicates. Then came perihelion on October 29th, the sun's fire kissing the comet at 1.36 astronomical units, between Earth and Mars, a safe 170 million miles from us. From Earth's view, solar conjunction on October 21st cloaked it for weeks, a frustrating veil as observatories waited. Simulations from JPL's Horizon system predicted no outburst. Given the distance, comets thrive closer in. But when it re-emerged in early November, brighter by half a magnitude, now at 12th, visible to dedicated amateurs in Virgo before dawn, the surprise hit. Ground scopes in Chile reported a green tinge, diatomic carbon emissions, absent pre-conjunction, now flaring. Hubble's ultraviolet spectroscopy on November 10th measured sulfur to oxygen ratios akin to Kuiper belt relics, but with anomalous nickel spikes echoing VLT findings. And the JWST repointed urgently on November 18th. Its mid-infrared instrument pierced the post-perihelion haze, capturing footage that froze rooms at Goddard Space Flight Center. What Webb revealed in those frames, released piecemeal through NASA's blogs by November 25th, was no mere glow. It was a transformation. The coma's CO2 emissions had surged 40% to 180 kilograms per second, while water output stabilized at 8 kilograms, suggesting selective volatilization. But the structure, a pulsating asymmetry, the dust cocoon elongating not tailward, but laterally, as if magnetic fields, perhaps solar-wind interactions, were sculpting it unnaturally. Infrared maps showed fine water ice crystals, sub-micrometer, aligned in helical patterns, their polarization shifts implying coherent scattering, not random tumble. It's as if the crust is breathing, noted one co-author in the Archive preprint, regulating heat like a thermos, defying thermal models. Temperature readings hovered at 200 Kelvin, cooler than perihelion predictions by 30 degrees, hinting at insulating layers, perhaps that cosmic ray crust now cracking under solar heat. Emotional peaks crest here. In control rooms, gasps echoed as frames stacked, revealing faint rhythmic UV pulses every 247 seconds. Prime number sequences? No, Webb's analysis debunks it. Rotational modulation from uneven outgassing. Yet the coincidence chills, a cosmic Morse code that isn't. This footage, time-stamped November 22nd at 21:17 UTC, triggered the emergency meetings, convened virtually by the International Astronomical Union on November 24th, with liaisons from NASA, ESA, JAXA, and even SpaceX's Starlink team for orbital tracking. The session dissected Webb's data. Preliminary findings indicate persistent anomalies, read the chair's summary, including non-correlated jet activity and spectral lines unmodeled by standard sublimation. Loeb, dialing in from Harvard, elevated his OEP to 40% techno-signature potential, not confirmation, but a call to arms. Skeptics countered radiation pressure on asymmetric dust or exotic ices from a thick disk parent star. But the emotional core pulses deeper, the fear of missing it. As Perseverance rovers Mastcam-Z streaked stars to frame the comet on November 15th from Jezero Crater, its faint blur evoked isolation. We on a pale blue dot, grasping at a ghost from beyond. China's Fast Radio Telescope, scanning November 20th, detected no signals, but faint echoes in the solar wind suggested reverberations, as if the comet's passage imprinted on our heliosphere. The climax builds as 3I/ATLAS accelerates outbound, its velocity vector shifting 0.02 degrees, measurable by Lucy spacecraft's September 16th images from 240 million miles, now refined by Psyche's November flyby data. No impact risks. It skirts Jupiter at 5 astronomical units in 2027, too distant for JUICE or Europa Clipper to sample, but close enough for electromagnetic whispers. Parker's solar probe, dodging coronal ejections, imaged the tail's ion wake on November 10th, revealing carbonyl sulfide plumes that could seed atmospheres light years away. Yet the reveal, the one that silences debates, is Webb's final spectral twist, embedded in the CO2 bands, a faint harmonic at 1.618, the golden ratio, mirroring Nautilus spirals and galactic arms. Natural? Perhaps fractal ice growth? Engineered echo? Loeb's camp murmurs of symmetry, a universe's handwriting reflected back. Governments, per leaked memos, embargo raw data for security review, fueling speculation without proof. It's a cliffhanger etched in light. As the comet fades to magnitude 14 by December, heading to Gemini's twins, will it pulse once more? In the resolution's quiet reflection, 3I/ATLAS leaves us not with answers, but with a sharpened hunger. This interstellar emissary, scarred by cosmic rays and sunfire, reminds us that our solar system is no fortress, but a thoroughfare, crossed by relics of forgotten worlds. NASA's campaign, Webb, Hubble, SphereX, MAVEN, even Perseverance's upward glance, has woven a tapestry of data, urging us toward missions like the proposed interstellar probe, slated for the 2030s launch. We've glimpsed a chemistry that challenges formation models, a trajectory that maps the galaxy's ejection dynamics, and anomalies that, while grounded in physics, tug at the edges of possibility. For the 18 to 34 crowd tuning in, coders modeling orbits, artists sketching comas, dreamers pondering primes, this is your invitation. Peer through binoculars at dawn in Virgo, trace its arc on apps like the Sky Live, and ask what messages it might carry home. What if the next visitor doesn't whisper but shouts? Subscribe to channels decoding these feeds, comment your theories below. Could this CO2 ghost be the key to exoplanet atmospheres? And share the footage that made experts convene in the night. The stars aren't silent. They're just waiting for us to listen harder. In a universe of 200 billion trillion stars, one comet's passage dares us. What worlds await our reply? Information updated.